Hey guys, today we are going to do a couple of these problems on circular motion together. We're going to do number 1, number 2, and number 6, which seems to be one that many people have questions on. So before we do that, let's look at the top and let's talk about these formulas way up top. So the first thing you see is the capital T equals time over revolutions or spins, however you want to put it. The capital T is going to be the time of one spin, one complete loop around the track, one complete circle. But that will be your time period. Going around the circle. The second one is your velocity. How fast is the object going in the circle? What is its speed as it moves around in a circle? So velocity is 2 pi r divided by your time period, which is the one before. Next one is centripetal acceleration. How fast is this object changing speed? Of course, it's going straight, then it's going to have to curve to go around with the circle. What is that acceleration? And then the last one, this is going to be force, centripetal force. How much force is felt on the string or on the person's arm or whatever it is that's spinning the object in the circle? So let's start off with number 1. It's asking, well, it's giving you the scenario. A race car makes one lap around the track with a radius of 50 meters in 9 seconds. So before you do anything, let's start off with the variables. Remember, variables, show me your work, and answer. So if you think you're able to answer the question without writing anything down, this will only confuse you and it's going to slow you down. So don't do that. So let's see what it gives me. Give me a radius of 50 meters. It also gives me a time of 9. It made one lap in 9 seconds. So the time period is 9 seconds. Why is it 9 seconds? This is the time. Over one lap, which anything over 1 gives you the number itself. So now I'm going to find velocity. Velocity equals 2 pi r divided by the time period. I'm going to put these parentheses up here so you could do the top first. Order of operation. Do 2 times pi times r, which is 50, divided by your time period, which is 9. Okay, so what do you get? 2 pi r is 50 divided by your time period. Insert your answer there. I will not do that math for y'all, but the velocity is meters per second. Second part of this problem is asking you for a centripetal acceleration. I don't know what that is. That is going to be my x. But up on top right here, you see acceleration equals velocity squared divided by your radius. We just talked about this. The radius of the circle is 50. Your velocity, whatever you get up here, move it down here. Just don't forget to square it. Last but not least, enter your answer here with the correct units. For acceleration, it's meters per second squared. So do all three sections. Okay, make sure you do your variables. Make sure you do your show me your work and your answer with the units for both. So go back and solve for this to get your answers. Question number 2. Normally neutrons swinging a rubber ball attached to a string over his head in a horizontal circular path. The piece of string is 1.5 meters long and the ball makes 120 complete turns each minute. So what is the velocity? That is what the question is asking. What information does it give me? Tells me that swinging a piece of string with the ball attached to the end of it in a circle. Piece of string is 1.5 meters long. Okay, so to keep things simple, his radius is the length of the string. We can ignore that he might be swinging his arms out a little bit just to keep it simple. Then my time period. My time period, once again, if you look at the top, your time divided by your revolutions or your spins. So my time in 1 minute, and you convert that to seconds. Okay. How many spins? 120. Right there. So 60 divided by 120, most of you could do that math in your head, is 0.5. Still looking for velocity. 2 pi r divided by your time period. Distance over time. So you're going to plug that in. 2 times pi times 1.5 equals, then divided by 0.5. That will give you your velocity. Good? Okay. Next, B is asking for your acceleration. I don't know. That's my unknown. That's my x. But acceleration, according to the formula on top, is velocity squared divided by your radius. See that? So what are you going to do? Move this velocity here. Don't forget to square it. Divide by your radius. You plug it into your calculator. Should give you your acceleration. Number 6, it gives you like 4 pieces of information right off the back. So what I'm going to do is I'm going to write these down. I'm going to read it. A 0.5 kilogram mass is attached to a string, 1.0 meters long, and moves in a horizontal circle, completing 1 revolution in 0.5 seconds. 0.5 seconds. Calculate. So my mass is 0.5 kilograms. My radius is 1.0 meters. How do I know? The string is 1 meters long. So just like before, you swinging it, it's 1.0 meters long. Okay? We're ignoring the extension of the arms. You might be swinging it. Let's keep it simple. It moves in a horizontal circle, completing 1 revolution in 0.5 seconds. Okay. So now let's start doing it. We need to do acceleration, but to get acceleration, we need to solve for velocity. But to solve for velocity, we need to solve for time. So let's do the time period. So up on the top, I even put them in order. Time period, you solve for this one, then you solve for velocity, then you solve for acceleration. So on your time period, it's your time divided by your revolutions, which is 1. Once again, any number over 1, it's the number itself. So capital T, your time period, is 0.5. 0.5 divided by 1. So let's solve for velocity. 2 pi r, which is 1.0, close parentheses, divided by your time period, which is 0.5. Get your answer, meters per second. Make sure you put your units. So you have, for this one, you have your variables, you have your work, and you have your answer with the correct unit. So now the next thing is you're going to calculate your acceleration. I already have my velocity. Velocity squared over radius. Move that velocity into that right there. Square it divided by your radius. So this first section, we did it to find the time period. Then we did this to find the velocity. Once we found our velocity, we're able to plug that in to your acceleration. Right there. So 2 times pi times 1 divided by 0.5 equals your velocity. Bring that velocity over, square it, and divide by your radius. So that will give you your acceleration. For B, it's asking for your force. You don't know what that is. But up here, the centripetal force on that string is equal to the mass of the object times its centripetal acceleration. So force equals mass times acceleration. What is the mass? 0.5 kilograms. Yep. What is acceleration? Whatever you got here, you plug it in there. Okay. So once again, to solve for your force, you're going to have to solve for acceleration. To solve for acceleration, you'll need to solve for your velocity. And to solve for your velocity, more than likely, you'll have to solve for your time period. Also remember, your force is in newtons. Okay, hope this helped. If not, please ask me questions. Thank you for your time.